Okay, here's how it's done. So first of all, since this is dealing with a string and resonance on a string, the equation that we will use is the frequency equals NV over 2L. This time we know that frequency of the third harmonic. We're eventually going to need to find length so that we can take 60% of its length and find the fundamental frequency. So the thing I'm solving for is length. When I solve for it, I get that length is equal to NV over 2 times the frequency. Here, it's giving me the frequency of the third harmonic, so N will be 3. V is not given to us, so we're going to leave it in there as a variable, over 2 times that frequency, 540 hertz. When I plug all that into my calculator, I end up getting 0.002778 V. I've just left V in there as a variable since it's not given to us. It'll end up canceling out. You'll see that in a minute. It tells me that I now have a length of 60% of that. And to get 60% of that, I multiply this number times 0.6. 0.002778V times 0.6 gives me 0.001667V. That's my new length, and that's what I'll plug into the new equation to find the fundamental frequency, or F1. Same equation here. N is 1. I'm going to leave V in there as a variable just as I did before since I don't know it. And then I'll have 2 times that new length, 0.001667V. Now notice that I've been careful not to round, because if I round even just a little bit, I'm going to get a hugely different answer since this is just such a small number. As you can see here, the V's cancel, so that's all good. And we get a new fundamental frequency of 300 hertz. One more example problem we're going to try. Again, I'll put it up on the screen. Go ahead and pause the video and try it for yourself. See how you do. Okay, back from trying. Let's see how you did. Human ear canal tells us that this human ear canal is like a closed pipe. Open at one end and closed at the eardrum. And we want to find its fundamental frequency, the frequency around which we would expect hearing to be the most sensitive. There's one thing a little bit different in this problem. It gives us the speed of sound at 340 instead of 343. We'll go ahead and use what it gives us. Since we're dealing with a closed pipe, Fn is NV over 4L. N is 1. Since we're dealing with the fundamental frequency, V, it told us, is 340 meters per second. Divided by 4 times L. And here we need to convert from centimeters to meters. So I will plug in 0.028 meters. Plug all that in my calculator, and I end up getting 3,035.71 hertz. One quick check I could do is make sure that's in the range of human hearing, and fortunately it is. That's the end of this video. We'll do one more example problem to start off the class on Wednesday to make sure you fully grasp it. And remember, there will be some practice problems posted on Edline so you can try it again on your own.